Okay, so sending a video from your phone to a TV, I mean, that is easy. It is a single direct line. But imagine walking into a sprawling casino sportsbook or a massive corporate campus where 1,000 different screens are all flawlessly synced to the exact same live feed.
Right. It is not just splitting a signal at that point. You are essentially building a private, high-speed broadcasting network from scratch. It requires just an incredible amount of processing muscle.
And that is exactly what we are unpacking in today's deep dive. We are looking at the exact hardware that makes that massive infrastructure possible. We are pulling from HDTV Supply's e-commerce catalog to look at one highly specific piece of enterprise tech. It is the Vitec AVSTR-E3830-HDCP-PRO AvediaStream encoder blade.
That is quite the name, honestly.
It really is a mouthful. But our mission here is to decode the hidden mechanics of distributing high-definition video at a massive scale.
Well, that specific Vitec blade is a perfect case study. I mean, if you look at the core specs, it takes a single HD HDMI input and it outputs it to up to 1,000 endpoints simultaneously.
Wait, so one single input to 1,000 screens?
Exactly. One input, 1,000 screens. But what is really fascinating here is the heavy lifting going on behind the scenes. It is not just duplicating the image. It is that HDCP professional specification in the name.
Right, because when you're distributing copyrighted material, like, say, a live sports broadcast, you have to prove you aren't pirating it.
Yeah, that is where the actual bottleneck happens. The source device demands an HDCP cryptographic handshake from the display. So a standard home setup might manage, 2 or 3 of those secure keys.
Okay, that makes sense.
But this VTech blade, it has to independently negotiate and maintain 1,000 unique cryptographic handshakes in real time.
Wow. So it is less like a water main pushing fluid to 1,000 houses and more like a bouncer at an exclusive club having to continuously check and verify 1,000 VIP passports every single second without missing a beat.
That is a great way to visualize it, because if even one of those handshakes drops or times out, the encryption protocol triggers a failsafe.
And the screen just goes black, right?
Yep, exactly. The screen just dies. The computational load to keep 1,000 secure keys active all at once is just staggering.
But I do have to push back a little on the resolution here, because when you browse HDTV Supply's catalog, they are heavily pushing these massive 4K and even 8K HDMI matrix systems.
Oh, sure, they definitely are.
So if I am building a state-of-the-art mega AV system today, why would I use a strictly 1080p encoder blade? I mean, shouldn't 1,000 screens be running in 4K by now?
Well, let us do the math on the network infrastructure you would actually need for that. An uncompressed 4K stream requires roughly 18 gigabits per second of bandwidth.
18 gigabits per screen.
Right. Now multiply that by 1,000 unique endpoints.
Oh, wow. So you are suddenly asking a local sports bar to manage 18 terabits of internal network traffic. You would need a multi-million-dollar data center just to route the cables.
Exactly. It would instantly melt down most enterprise network backbones. And that is why this 1080p hardware is still the ultimate workhorse.
Because by capping the resolution, the hardware dedicates its processing power entirely to frame perfect synchronization.
Yes, and maintaining that massive cryptographic load. I mean, in commercial AV, a totally reliable 1080p image is infinitely better than a 4K image that stutters or suddenly drops to a black screen.
Which explains why the single blade does not just exist in a vacuum. To actually handle all that routing, you need a sprawling ecosystem.
Oh, absolutely. It is a massive setup.
Yeah, HDTV Supply lists over 2,000 modular matrix switchers, thousands of accessories, and these strategic integrations with massive brands like Dell, Canon, and Bose.
Right. You are building out entire server racks of highly sensitive gear. And if we connect this to the bigger picture, configuring all that gear requires an incredibly specific type of engineering expertise.
Which brings up the hilarious human element behind all this hardware.
Yeah.
I was looking at HDTV Supply, and they have a 4.7-star rating, but the reviews themselves are just amazing.
Oh, really? What do they say?
Well, one customer left a 5-star review and literally said the staff was less than friendly, but answered my question regarding some highly complex 1080p 60 frame rate resolution routing.
That is incredibly fitting, honestly, because in the enterprise infrastructure world, bedside manner simply does not matter.
Right. You don't care if they say hello with a smile.
Exactly. When you are 20 minutes from the Super Bowl kickoff and a routing protocol is failing across your entire video wall, you don't want a cheerful customer service rep.
You want the grumpy genius who knows exactly which HDCP handshake is timing out. It is exactly like finding a brilliantly cranky auto mechanic. You tolerate the attitude because they are the only ones who actually understand the engine.
That is so
So
true.
the next time you are sitting in a massive venue, looking up at hundreds of perfectly synced screens, you will know there is a hidden, incredibly complex ecosystem of encoder blades and probably a few grumpy geniuses making that magic happen.
It really does make you wonder about the life cycle of that physical infrastructure, though. I mean, if a single physical hardware blade manages 1,000 encrypted endpoints today, what happens when AV distribution inevitably transitions entirely to cloud-based routing?
Oh, that is a great question. Does hardware like this VTech blade just disappear entirely, or does it evolve into something completely invisible, managing even heavier cryptographic loads from a server hundreds of miles away? Well, that is definitely something for you to mull over the next time you look at a giant wall of TVs.